Application of simple pendulum. Simple pendulum. We have a light string of mass m and length l. What is time period for this type of oscillation? We all know time period is 2 pi under root L over Z. L over Z. This upper part is a fixed one, so we have to use this equation. If other end of the string is fixed, general formula comes out to be T equals to 2 pi under root L over acceleration effective. Case 1, suppose there is an elevator or there is a van moving with a constant speed c or v, and there is a pendulum, length L, mass m. In this case, frame is inertial, so time period remains the same, 2 pi under root L over Z. 2 pi under root L over Z. Suppose now the elevator is going upward with constant speed. Here also time remains the same because frame is same inertial one. If this elevator goes with constant speed downward, the result will be the same one. Now what will happen if the elevator accelerate in any direction? Suppose in case 3rd, elevator is going up with some acceleration. Suppose acceleration of the elevator is a0. Here mass of the pendulum is m and length is l. What will be the time period of oscillation in this case? So if we consider an observer inside the frame, for this non-inertial observer, a pseudo force ma0x, mg is the weight, so overall weight acting on body is ma0 plus mg, or m into g plus a0. It is balanced by the tension T dash. So effective acceleration is g plus a0. So effective acceleration is, this is our effective acceleration. So time period comes out to be 2 pi under root L over G plus A0. What will happen if elevator goes down with some acceleration A0? For this non-inertial observer, pseudo force now acts upward and tension also acts upward. Both forces balanced by mg. So what is now the effective acceleration? Now effective weight is upward direction T, downward total force is m into g minus a naught. So this is our required acceleration effective. So time period comes out to be 2 pi under root L over g minus a naught. What will be the effect if a van goes along a horizontal direction with some acceleration a naught and there is a simple pendulum of length L mass m? For a non-inertial observer, forces acting on the bob is a pseudo force ma0, weight is mg and tension is T. So there is a net leftward force ma0 which is balanced by the tilting of the string. So final diagram becomes like this. Here leftward force is ma0, downward force is mg, and both forces have a resultant in this direction, that is under root a0 square plus g square multiply m. This is balanced by the tension. So here is the effective acceleration. Effective acceleration here is under root a0 square plus g square. So what is the time period? Time period is 2 pi under root L over effective acceleration, that is a0 square plus g square. Now suppose this fixed end is not remains the fixed one, but this end is accelerating. Someone is pulling upward with an acceleration a0 and there is a bob of mass m length L. What will be the time period after oscillation? By using Newton's law, all forces acting on the bob are T, downward force is mg and acceleration is a0. So using Newton's second law, T minus mg equals to ma0. So T is what? M into g plus a0. And T dash is the tension. So T dash over m is what? G plus a0. So this is our effective acceleration. So time period comes out to be 2 pi under root L over g plus a0. Suppose in a question it is mentioned that this end is accelerating upward with an equation y equals to kt square. Now what is the time period? For this pendulum? So this is displacement of this second end. So differentiating it, we get a speed 2 kt and again differentiating we get acceleration of 2k. So using Newton's law, net acceleration is 2k, downward force is mg and tension is T dash. So using Newton's second law, T dash minus mg equals to m into acceleration is 2k. So T dash is what? M into g plus 2k. So this is our required effective acceleration. So time period is 2 pi under root L over effective acceleration is g plus 2k. What will happen? Pendulum time period in case of electrostatic field. Suppose there is a simple pendulum and at the suspension point there is a mass q and at the above mass is m0 and charges are q0, length is l. What will be the time period in this case? What will be the time period in this case? We all know forces are mg, electrostatic force downward is k q1 q2 by r square, so net force is this one, and if taking mass common, this comes out to be g plus k q q0 over ml square. So this is our required effective acceleration. So this is our required effective acceleration. So what is the time period? What is the time period? Time period is 2 pi under root L over effective acceleration is g plus k q q naught over m l square. Suppose in a question of simple pendulum, length is L, mass is m, and charge is given q0, and there is an electric field all over the space downward and magnitude e0. What will be the time period in this case? Making free body diagram of the bob, upward force is T, downward force is mg, and another force is QE0 because electrostatic force is QE. So T equals to mg plus QE0. So taking m common, g plus QE0 over m. So this is our required effective acceleration. So effective acceleration is g plus QE over m. So time period comes out to be 2 pi under root L over g plus QE0 over m. G plus QE0 over m. In the same question, if electric field is acting vertically upward and pendulum is like this, mass m, length L, what will be the time period? Obviously, taking FBD, tension is T upward, mg is downward, and charges is q0, so forces are q0 into E. So T plus q0 is balanced by mg, and what is T? T equals to mg minus q0 e0. So taking m common, g minus q0 e0 over E. This is our required effective acceleration. So time period comes out to be 2 pi under root L over effective acceleration is g minus q0 e0 over m. What will be the time period if constant electric field goes along horizontal and pendulum is like this? Masses are m and l. Charges given is q0. So here taking FBD, upward force is T, downward force is mg, and this rightward force due to electrostatics is q0 e0. So now a string goes like this due to this force, and the final diagram is this. Force is q0 e0, weight is mg, and resultant of this one is balanced by tension T dash. So what is T dash? T dash is under root mg square plus q0 e0 whole square. So T dash equals to, taking m common, g square plus q0 e0 by m whole square. So this is our required effective acceleration. So time period comes out to be 2 pi under root L over under root g square plus q0 e0 over m whole square. Now suppose a simple pendulum is in a frame that is going downward surfaces are smooth with an acceleration we know g sine alpha, because if surface is smooth, acceleration of any body along the incline is g sine alpha. So initially pendulum is along this line. If there is an observer inside the frame, they will apply a pseudo force mg sine alpha, and weight component is already mg sine alpha and mg cos alpha. So mg sine alpha gets cancelled. Only force that generating tension is mg cos alpha, and that is perpendicular to the plane of the incline. So the final alignment of the simple pendulum is along this line. Here tension is balanced by mg cos theta. So T equals to mg cos theta. Here effective acceleration is g cos theta. Effective acceleration is g cos theta. So time period comes out to be 2 pi under root L over g cos theta. Now suppose there is a wall. Suppose there is a wall and there is a simple pendulum. Length L, mass m. All collisions are elastic. All collisions are elastic. What is the time period? What is the time? Simple pendulum goes like this. After hitting this goes like this one. So what will be the time period? Obviously half of the complete time, because time decreases by this part, that is exactly half of the total. So time period comes out to be pi under root L by g, or 2 pi under root L by g by 2, pi under root L by g. If wall is partially elastic, what will happen to the time period? What if partially elastic, only amplitude decreases. Suppose this angle is theta naught. After collision, energy losses and body goes like this one, and again body goes like this, and again comes out. Energy loss occurs continuously, but the time period always remains the same. That is 2 pi under root L by g by half. That is pi under root L over g. Suppose wall is not complete but the partial one, like this. Length L, mass m, this length is a. Now what will be the time period for this simple pendulum? Pendulum goes like here, goes like this. Now after this instant, pendulum goes along this line. So this combination may be treated as two pendulum, one of length L minus a, and other of length L. The time period, total time period will be the T1 plus T2. What is T1? Obviously time period depends only on the length, so T1 is pi under root L over g, and what is T2? Pi under root L minus a over g. So total time period comes out to be pi common, under root g common, under root L plus under root L minus. This is our required time period. Next, suppose there are two identical pendulum. Making angle theta naught. of same length. What will be the time period for each one? All collisions are elastic. All collisions are elastic. Masses are same. What will be the time period for each one? Time period for each one. What will be the time period for each one? We all know if collision is elastic, both comes here, and before collision a speed is v and v. Then after collision also a speed remains v and v. So there is no change. Only change is that bob A only moves in this path. That is half of the complete oscillation. So time period for each one comes out to be pi under root L over Z. Pi under root L over Z. Suppose in the next part, suppose this angle is alpha. This angle is alpha and this angle is 2 alpha. And there are two bodies of same mass, m and 2m. This one is our first bob, this one is our second bob. Find time period of each pendulum. Find time period of each pendulum. How we can calculate time period for each pendulum? As body comes nearer, here lengths are the same. As body comes nearer, a speed is v equals to omega into a1, and here speed is omega into a2. What is amplitude? Here angle is alpha and this length is L, so amplitude is L into alpha. So omega L into alpha is the V1, and what is V2? Omega L into 2 alpha. So here speed is 2 times. If here speed is V0, here speed is 2 V0. As masses are identical, and collision is elastic, there is velocity exchange. So if first bob moving with the speed v0 and second bob moving with the speed 2v0, after collision only effect is the exchange of velocity. Before collision pendulum situation is like this, and after collision first one moving with the speed 2v0 and second moving with the speed v0. Only differences. Second one moving with the speed v0. So now this will gain a angle of 2 alpha and this will gain an angle of alpha. And time period for all remains the same, pi under root L over Z.